Bismillahirrahmanirrahim. On the demand of Nazneen from Kurdistan, North Iraq. This problem is related to trigonometry. Prove that cos of I natural logarithm of a plus ib upon a minus ib equal to a square minus b square upon a square plus b square. We have to prove this equation. So we first take left hand side, and by solving then we go to right hand side. Left hand side is cos of I natural logarithm ln a plus ib upon a minus ib. We can write natural logarithm as log of base e a plus ib upon a minus ib. There is not necessary to write this step, but we write because most of us are not familiar with ln, which is natural logarithm. Now we apply the simple formula of logarithm log m by n. We know that this value is equal to log m minus log n. So apply here. Here m is in place of a plus ib, and n stand for a minus ib. So apply this formula here. We get left hand side equal to cos of I flower bracket. We apply this formula and we get log of a plus ib minus log a minus ib. Now I apply again a formula for logarithm of complex quantity log x plus iy equal to 1 upon 2 log of square of real part plus square of imaginary part plus I into tan inverse imaginary part upon real part. Similar formula for log x minus iy by replacing I by minus I, or by conjugate property we get another formula, similar formula 1 by 2 log of x square plus y square. Here we see that real part of both formula are equal, but imaginary part differ by minus sign, tan inverse y upon x. So we apply these two formula for here and here. So we get left hand side equal to cos of I write I out of this bracket. We can write I here and here. So I write I outside the square bracket and apply formula this formula first for this, and we write the value in this floor bracket log a plus ib, which is equal to, according to formula, 1 by 2 log of real part a square plus imaginary part v square plus I tan inverse imaginary part upon real part. This is equal to value of log a minus ib. Now we write the value of log a minus ib according to formula. I write 1 by 2 log of a square plus b square and minus I tan inverse image v upon a. This value is according to formula which I explain here. Now we should open this bracket, and because default sign is positive, so there is no change in sign in these two terms. We write these two terms without any change. 1 by 2 a square log a square plus b square plus I tan inverse b upon a. But here we see sign of in front of bracket is minus, so on open the bracket, the sign of the term will be changed. So this sign is positive, but after breaking the bracket, this value becomes negative 1 by 2 log of a square plus b square, and minus multiplied by minus, we get plus I times tan inverse b upon a. Now we are seeing here these values are positive and negative but equal, so we cancel out these two values, and again we see these two values are equal. So we write 2 times I tan inverse b upon a. Now I take I in this bracket, so we can write it as I square and 2 times of tan inverse b upon a. I take 2 with the tan inverse because we have formula for this. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So we apply this formula, so that remove 2 from here, we get left hand side cos of also we know that value of I square, since I is a square root minus 1, therefore I square equal to minus 1. So we write here minus 1 in place of I square, and apply this formula, and x stand here for b upon a. So we write this value, apply this formula, we get tan inverse 2x means b upon a upon 1 minus x square means b upon a whole up square. We know that cos minus theta equal to cos theta, so we replace we apply this formula, and we get cos of tan inverse 2ab upon a whole upon 1 minus b square upon a square. After taking LCM, we get cos of tan inverse 2b upon a, and we take LCM 1 and a square multiplied to 1, we get a square, and 1 multiplied to b square. Now we know that this value is equal to bottom, and this value is double upon, so this value is multiplied to numerator a square, here a square, and this value is we need this value, this sign upon a square minus b square, and we should cancel out a, and we get the value cos of tan inverse 2ab upon a square minus b square. Now we have to cancel out these two by apply formula, or we can draw rough work as if we in right angle triangle, if we this angle theta, which is equal to this, if we let theta equal to tan inverse 2ab upon a square minus b, and we take tan inverse to left, then tan theta is equal to 2ab upon a square minus b. We know that tan theta is a ratio of perpendicular and base. perpendicular is opposite to theta, and base is remaining side after we declare this hypotenuse, which is opposite to 90 degree hypotenuse, and remaining side is base. We know that tan theta tell us the ratio of perpendicular upon base. So P is equal to perpendicular is equal to 2AB, and base is equal to a square minus b square. By Pythagoras we can find the value of hypotenuse, which is equal to square root base square whole of square plus perpendicular whole of square, 2AB whole of square. If you feel any problem here, you can tell me, I will explain this. So by this we can, if we can change this into tan theta. If by this we can this cos theta, or we can also if we take is theta, this value is theta, therefore we have only find, and if we write theta here, then this will be not rough work, this will be fair work. You can draw this figure and find the value of cos theta. We get value of cos theta by ratio. We know that cos theta is ratio of base upon hypotenuse. So here base is a square minus b square, and hypotenuse is equal to square root a square minus b square whole of square plus 2ab whole of square. We have another method to solve this problem, but one of problem is this. If you have any problem, I can explain by formula. I think I will explain this by other method. If you feel any difficulty, you can try after this. You can add after this step, because I now I will continue. This is value equal to a square minus b square square root. So taking whole of square, we get value a square whole of square plus b square whole of square. First quantity is square plus second quantity is square, and minus 2 times of first quantity into second quantity, which is whole of square of a square minus b square. Now I write the value of this by squaring. We get 2 square is equal to 4, and a square equal to a square, and b square equal to b square. This value is equal to left hand side. So after solving, we get right hand side. By this we can prove. We write a square plus b square, and difference between these two terms is plus 2a square b square. A square minus b square upon square root. This is also whole of square of a square minus b square, according to formula x square plus y square plus 2 xy equal to x plus y whole of square. Square root cancel out this square, so we get a square minus b square upon a square b square, which is equal to right hand side, which was to be proved. Hence proved. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.